Welcome to the presentation of our Kinetic Adaptive Origami Sunshade, abbreviated as KAOSS, which describes our project process over the last months quite well. Why? Let us tell you our story. We are Sophia, Marilse, Trisha, Mariam and Franzi. It all starts with the problem we wanted to solve. The existence of glazed high-rise buildings which have a high cooling demand because of overheating, as well as large facade surfaces which are not utilized for energy production. Furthermore, during our research phase, we found out that fixed shading systems lead to a blocked view as well as a lack of incoming daylight. Therefore, we created a kinetic second layer facade with integrated photovoltaic modules that can be applied on glazed high-rise buildings with a high energy demand, generating energy and shading during sunny hours while enabling view and daylight inside. The shading modules expand when there is much light income to prevent the building from overheating and the occupants from experiencing glare. On cloudy days, when there is less light, the modules close and shrink to enable sufficient daylight income. The PV modules are always oriented to the outside to generate energy. The parts between the modules are filled with a translucent shading fabric to allow view from the inside. We found inspiration for our module's shape mainly in the field of origami, with its large variety of shrinking and expanding patterns. As you can see, we tested a number of different folding patterns and shapes for our shading modules. After evaluating these different patterns based on different parameters like the modular placement on the facade, the aesthetics, the complexity of the movement, and a balanced PV shading ratio, we found the most suitable shape for our design. The daisy, the shading module which opens and closes like a flower. Look how nice your working space appears with this module applied to the facade. We chose the module's diameter of 2.3 meters to create the same module placement in each story. Let's have a closer look at the module's components. The PV panels and the lightweight shading fabric are connected by clamped steel profiles which enable the folding of the module. The flexible shading fabric is stabilized by a grid made out of steel tubes. Now, the most challenging part of our KAOSS project began, finding a suitable mechanism. Honestly, it was a roller coaster experience, consisted of building a lot of models, testing them, failing, adapting the models, having success and learning a lot about movements. We tested a variety of different mechanisms, from which we are going to introduce you the most promising developments. The aesthetically most appealing mechanism we tried is the scissors mechanism. The movement works smoothly because it translates the three-dimensional movement of the module into a two-dimensional movement. However, when applied on our module, all points of the mechanism are moving, so a placement of the modules directly next to each other is not possible. As our product is a shading device, however, the complete coverage of the facade is very important. Therefore, this mechanism is not suitable for our system. Another mechanism we have tested works by pulling the edges of the module, which are connected to a frame with elastic connections. When releasing the force, the edges spring back into its original position. The challenge we were facing here was the required elasticity and at the same time stability of the elastic material. In real dimensions, these springs would have to be able to expand from 3 to 50 centimeters, and we were not able to find such a material in reality. Therefore, we made some adjustments and came up with the double pulley mechanism. Here, ropes are connected to the 6 edges of the module, while one side of the ropes gets pulled for expanding the module. Pulling the other end of the rope leads to its folding. Unfortunately, we were not able to develop this mechanism into detail, but in our opinion, it has a lot of potential. Now, let's apply our shading system on a glazed building. A horizontal steel grid is connected to the ceiling of the building. On top of this, a vertical steel grid is placed. Finally, a hexagonal grid in which the kinetic modules are placed is applied and improves the aesthetics and reduces the cooling demand of the facade. Have a look at this beautiful impression and how the modules change according to the sun path. The movement is regulated by a light-sensitive sensor. To conclude, we have created a unique shading product with an extraordinary aesthetic impression and a sustainable approach. However, we have to admit that we do not believe this product would survive in the mass market. The complexity of the kinetic system leads to high production costs as well as a time-consuming maintenance. We have learned a lot about testing by doing during the Bucky lab, about product development and about different mechanisms, and are very proud about the achievements we have made so far. Nonetheless, there is a long list of further developments to be done if we had more time for this project. We would like to really develop the mechanism further in detail, find the right balance between stability of the structural grid and the view by experimenting. Furthermore, the assessment of the indoor environment is a crucial part for the success of our product. Therefore, we prepared a pre-occupancy experiment setup to answer the question, what is the influence of the kinetic shading system on the indoor thermal comfort of the user? First, a reference building needs to be chosen according to different selection parameters like a high energy demand and suitable surroundings for the implementation of PV modules on the facade. Second, a 3D module of the reference building in different stages is created. The building without shading, with a static shading system, and with the developed kinetic shading system. For these 3 different stages, the indoor temperature is simulated with an annual thermal simulation. Finally, the collected data can be analyzed by comparing and interpreting the results of the 3 stages. Thus, this experiment will show if the kinetic shading system improves the thermal indoor comfort and bring us closer to the success of our product. Thank you.